Okay, and welcome to those of you joining the LeedsAzure user group. This is the second meeting that we've done, and this is the second session where we've got James Randall, who's a recent Microsoft MVP as of May last month. So welcome to the MVP community, James, from fellow MVP here, Ryan Yates. We're going to be talking, or James is going to be talking today about writing elegant Azure functions, and I will let James take the floor from this point.
Hi everybody, nice to meet you all. I think I've spent about 10 hours on Teams today, so if I start to mumble or dip, give me a nudge. And I think this is the first meetup I've done online. I've got another one later in the week as well, so it's a bit of a new experience for me presenting to the empty screen. So yeah, as Ryan said, I'm going to talk a bit about Azure functions, sort of half about serverless architecture and how it applies to Azure functions, some of the ways I've used it successfully and unsuccessfully, and we'll spend the second half looking at how you could implement them in what I think is a more elegant, testable way in C#. So we'll get going. A tiny little bit about me. You can find me at the normal places, Twitter, GitHub. I've just noticed my Twitter link is actually my GitHub link. So Twitter, GitHub, my blog. On Twitter, I'm Azure Trenches, James Randall, you'll find me. I work for a company called Juniper Education. I used to freelance, essentially as a C#/Azure consultant, building systems for people independently. I joined Juniper as their CTO about 7-8 months ago. And as a sideline, I also have this project on the go, which is another Azure-based project, which is around cycling data analysis, which also makes use of Azure functions as well as F# and Docker and all sorts of bits and pieces. So I've got quite a background in Azure and kind of building systems with it, and I've spent a lot of time building with Azure functions in the last couple of years. So Azure functions, what are they? If we start at the beginning, they're often sort of put forward as Azure's serverless offering, serverless compute offering, and they are that, but it's not how I think of them, because it's just one mode in which they operate. I think they're better thought of as event-based functions as a service programming model, and they just happen to have a serverless hosting model alongside it. So you can run them on something called a consumption plan, which is the serverless model. You can run them inside application instances. You can run them on Kubernetes. You can run them in all sorts of ways. And many of those ways are not serverless offerings, but you can run them in the consumption plan, which is the serverless offering. It was very much a response to AWS Lambda, and there's no shying away from it, in my view. It was rushed to market, and you still feel some of the pain from that, particularly in how the sort of SDK manifests itself to you, the libraries manifest themselves to you. You can see, particularly worked with it from the early days, it was a bit of we need to get something out in a short period of time. So what are the components we can use that we've got to get this out quickly? And you still feel the pain from some of that, and we'll talk a little bit about that. And I think it led to quite an ugly programming model. So it was based around the web jobs framework, which you may have come across on Azure. That's been on there for a good number of years now, probably about 7 years maybe. So it's kind of attribute based. It didn't support dependency injection to begin with, which is can be problematic in C#, particularly with the way a lot of open source packages present themselves. It just felt, to me, it feels uncomfortable and unwieldy. There's also something which is quite unique to Azure functions, which is they have an orchestration model that lets you orchestrate numerous functions and coordinate their activities. I'm not going to talk about that here because it's a massive topic, but it is quite interesting to look at, and quite well documented and fairly unique. So that's quite an interesting model they have. And I think they've kind of built that and some of the other bits and pieces around it, knowing that their pure serverless offering is a little bit weak. And again, we'll come to that. So in theory, the kind of serverless world, I think everybody's familiar with this term now, and they kind of understand that it's not really serverless. As to begin with, there was a lot of debate about the kind of purity of these models and things, as is always the way. But in theory, it's infinitely elastic. It can scale to 0 and scale forever, and you don't have to do anything to enable that. that's a theory or a promise. There's a very low management overhead. You're not managing servers, you're not managing instances, you're not managing containers. You're just executing code functions, and somebody else is doing all the management for you around that. And finally, you're not worrying about servers. So in practice, how close does Azure get to that with its kind of consumption plan and its serverless offering? So I'm just popping up from the chat window in case anybody was asking any questions. So in practice, the infinite elasticity, does it scale to zero? It definitely scales to zero. When it's at zero, you pay nothing. It sits there and it wakes up when you ask it. When some work arrives, it does the work and it goes back to zero. And that can be fantastic if you're working in a kind of like spiky load environment, or you're running on a really tight budget. I just work for a charity where, they were very concerned about budget. A high burn rate on Azure meant they didn't have a business. And Azure Functions helped them out massively there. And I'll talk a bit about that in a moment. Does it scale forever? It goes a long way. But you can, on consumption plans, start to hit some limits around connections. You're limited in the kind of things you can do. There is a hard limit, but I can't quite remember before you have to ask for more. But it does go a very long way. There's some guys I know in Cambridge who've done some massive scaling with it. It goes a very long way. It goes far enough that if you're worrying about the kind of scale you're getting to, you're kind of worrying about that scale inherently. It'll get you a very long way. You do need to watch the back pressure as it scales up. So a common scenario I unpicked when I was freelancing was, we've got these Azure functions, and that's great, we're running really well, but our database has collapsed. And the compute can suddenly outstrip the resources that people have allocated in non-serverless Azure resources. So lots of things are going serverless in Azure, but SQL database traditionally wouldn't be serverless. Cosmos didn't auto scale. There's lots of things that don't scale endlessly and as easily as functions do. And what can happen is they get overloaded, and then that kind of backs up and it collapses. And tied to that, with Azure functions, you've got very limited control of the fault tolerance strategies. The fault tolerance is really baked into the function. If there's something on a service bus, Azure functions will pull something from the service bus, and you have to put the error handling, the fault tolerance inside the functions, which can sometimes limit. You can't always handle things how you might want to. You can't easily implement a circuit breaker that you don't pay for. You have to pay for checking the circuit is open or not, which is not ideal, and it involves an external resource. Interesting, that's a good use for a durable function, a circuit breaker. It does succeed with low management. I handed the solution over to a charity, and they're not a technical group. They've got some slight technical expertise, but we're not a technical group, and they've done nothing, and I've done very little maintenance for them. I do the occasional bit of maintenance for them still. I didn't want to leave them swinging when I stopped freelancing, but we're a good bunch of people, so I still help them out, but I don't really do anything. It's very low maintenance. In fact, they've been with the COVID situation, they closed down for 2 or 3 months, and we're reopening now, and things are just fine. They're ticking along as they were, and they've not paid for very much at all in that interim. Don't worry about servers. Yeah, you don't worry about servers, but there are some limitations. So there's connection limitations, outbound connection limitations. I think it's 300 connections, which you can hit. There are cold starts. So if you look at how Azure Functions is architected, it's essentially built around very small app service instances. I think using the new compute sort of ways they measure it, I think it's a V100 in terms of kind of like capacity, CPU and memory. It's very small. And what they do as things scale up, as the demand comes in, is they add more of these things in. But as they're added in, they have to warm up. They have to load .NET if you're running in .NET. They have to load some JavaScript infrastructure if you're running a JavaScript function. And if you care about latency, that can be a problem. And on the consumption plan, there is no real solution to that, and it's not a great story. The times for cold start are not good. There's a chap, another MVP called Mikhail Shilkov, and if you're interested in how things perform, he tracks it on his blog. He regularly updates it across all the cloud vendors and with the different languages and runtimes you can use for functions and Lambda and things. And unfortunately, .NET on Azure comes off pretty badly. You can do little things to work around that. If you're running at a very small scale, you can run a timer inside one of these function apps, and that'll keep things alive for you. But if you ever scale up to the second server, the first few requests on the second server will hit this cold start problem. The other potential solution to it on Azure Functions is to go for the premium plan. So they have something called a premium plan, which essentially is a managed app instance environment. It's quite expensive. I've never used it as a result. By the time we've got to that point, we've gone functions aren't a good fit, and the constrained programming model combined with a bigger bill just makes no sense. So we've normally gone down some other route, be it Docker containers or whatever. If you require VNets, they require dedicated servers, and the consumption plan doesn't support them. So again, you're pushed away from functions, at least serverless, and back into the premium plan. So you do, there are still servers there, and the way they're fronting up this consumption plan to you does bring some limitations. But there's a lot of benefits too. So some examples of how I've used this, where it's worked for me and where it hasn't. Just I think it helps illustrate some of the pros and cons. I did a fairly big project for this charity I was talking about called Bookmark Reading, who are about helping kids to read. There's an awful lot of kids in this country at a young age who struggle, who don't get support in learning to read. And there's a lot of research that shows if you don't get like early start with reading, it massively impacts your outcomes later on in your education and in your career. So there's a number of charities in this space, and Bookmark are one of them. And they wanted to take a kind of modern technology approach to this. So some of the charities I've seen in this space, they're quite form heavy, paper heavy. It's quite a heavyweight process. And Bookmark wanted to do it through the kind of devices that their target audience, which is probably early 20s to early 30s individuals who are going to go and help kids read, they have mobile phones and they're used to doing things, in browsers or on apps. So they wanted a technology solution that would fit into that audience, which I subcontracted some small parts of it, built for them, and we built it on Azure Functions. So the only compute resource in this solution was Azure Functions running on the consumption plan. And it worked really well for them. Latency was not the fact that every now and then it would take 3 seconds or 2 seconds to respond to an API request. That wasn't an issue for the charity, and it wasn't an issue for their audience. It wasn't driving people to a shopping basket like in Amazon. It was acceptable for their environment, and it brought this scale to zero. So their running budget is absolutely tiny, and all it's really costing them is storage and things like SQL. And there is a small Cosmos instance in there, which actually we'll probably take out at some point because for reason we put that in for a different reason and never used. But you know what development's like. It doesn't always go perfectly, but it is used and it works, and they've got a very small overhead in terms of cost for it. And we run, in fact, 3 environments, a sort of development environment, preview environment, and a live environment, and it fits inside the sort of charity plan of Microsoft. So they're essentially getting it for free. But there was also a deadline when we built this. It had to be ready within 5 months of them engaging with me, and the sort of zero overhead of managing Azure Functions and having to worry about complicated deployments and orchestrations of things was fantastic, because it meant I didn't have to worry about any of that. I just wrote the business logic, and I had Function Monkey, which I'll talk about a little later, that let me focus purely on the business logic, and let me be very effective and build what we needed. So that was a fantastic success. It was a great use of Azure Functions. and it's still running now, works really well for them. And that's for charity. I should have popped that up a bit earlier. You can see there the sort of stats in terms of kids leaving primary schools who can't read well. It's not great, and hopefully we've helped them out a little bit. I should say I was freelancing, and I definitely did not gouge money out of them. I gave them a very discounted rate because it was a nice sector to be in, and it was like an epic win for us all. I got to build a fun project, earn some money. They got good value. We got the solution at the end of it, so it was a really fun project, and one of my favourite projects I've worked on, and I've worked on a lot. A second example was a major sporting event. So they wanted to broadcast geodata to an audience, basically, on a map. So something would move on a map. It was a very spiky load over a few days with really quick ramp ups, and then it would fall off after a few hours. The requirements were really simple: share some geodata, a tiny development team, a tiny operational team, and we built that around Azure Functions and SignalR. And again, that worked really well. The only issue we had was with there's a serverless offering of SignalR, which works fantastically. Like, you can get using it with Azure Functions in no time at all, and be doing really cool stuff with your browsers. If you use SignalR, it enables some really compelling use cases that users go, oh wow, that's great. It can help with really compelling experiences. But their serverless offering, which joins up to Azure Functions really nicely, doesn't actually have an auto scale, or it didn't have the time. I think there might have been an auto scale at build, but I could be confusing it myself with something else. And there was some quite complicated script had to be written, not by me, but by the team I was helping, to get that working. So that was the slight drawback. But functions, again, the function part of it worked really well. There was nothing to do, and it just worked. So that was another great example of functions being used. An example where it didn't work out so well was an organization using basically the mobile payment processing, and they get a very high volume, and they were looking to move off a older architecture onto a more modern architecture. And it's a lot of it is message bus based and message based, so there's lots of messages, really high throughput of service bus messages, and you look at that, I think this is a great fit for functions. And from a pure technology code point of view, a developer's point of view, it really was. But the problem was it needed VNets, and it needed better control of the fault tolerance. We couldn't have things hammering away on resources, looking for things to do. It needed proper circuit breakers on the edge, outside of runtimes, and it really did need VNets. And when you looked at all that, moving to the premium plan just didn't stack up financially, and you could do a more efficient solution using containers, basically. So it didn't work terribly well in that situation due to some of the restrictions around the technology, the sort of consumption-based technology. Finally, another example, which this has worked quite well, but it's probably not the right fit for functions, but it got me going. So I mentioned at the start, I'm building my sort of side project is this cycling analytics website, which if you're a cyclist, please check out and give me feedback, because it's kind of like in early access. It's free to use, and I just want feedback. So if you go check it out and you're a cyclist, let me know. But one of the things it does is it does quite a lot of number crunching. So every second, if you've got a cycle computer, every second there's a bunch of measurements being taken from your bike. So how much power you're putting through the pedals, how fast are you going, how fast are you turning the pedals, what's your heart rate. There's all these metrics kind of getting captured every second. So you can imagine over a 4-hour ride, that's actually quite a lot of data. And as I look at this data to present it to people, to let them improve their performance, you want to look for patterns in the data. So a common pattern is, how long can you hold a certain power for, or over a 20-minute period, how much power can you put out? And if you see all the pro cyclists and the things like the Grand Tours, which are on TV quite a lot these days, it's all about how much power they can put out compared to their weight, particularly on hills. So there's some really key data there, and to do that you have to do a rolling average essentially over quite a lot of data. and over lots of durations, so 20 minutes, 5 minutes, do it for heart rate, do it for power. There's a whole bunch of stuff that you need to go and analyze, which lends itself to sort of a fan out approach. Someone uploads the data and you just want to say to some runtime, here's 200 calculations to run, please, which is a great fit for functions. A fan out pattern is a common serverless pattern. Just throw a whole load of requests at a serverless backend and let it handle them. So you think, great, that sounds like a good fit. The problem is running those kind of calculations in a consumption plan quickly rubs up against the limits of the consumption plan. It's a very limited CPU. There's not a lot of memory there. So you have to take a lot of care if you're doing something like that to squeeze things into memory. And the other thing you find when you do that is some of the other kind of weaknesses, that the unit of scale for those other functions is the function app. So all the functions you've got in this app scale together inside an app instance. And if you've got, for example, these things they weren't massively long running, but they would consume a significant amount of memory and they would keep a CPU busy, it caused problems with the chattier functions that were doing more casual message processing and some of the coordination and orchestration work. And that actually stopped the scale controller from being able to kick off scale jobs. And I started to get lots of errors with lost messages. I mean, the messages didn't get lost from the service bus, but it ended up in a dead letter queue. And there was a lot of chatter around the scale points. It was just struggling to scale. And that's because of that, again, this model, everything, the scale being a function app. So if you look to do something like this, and you want to make heavy use of functions and make them scale, again, you do have to be mindful of the environment you're working in. And the general guidance I would give is to separate things out based on their characteristics. So the cycling app ended up with several function apps, some of which deal with calculations, some which deal with orchestration, and some which deal with upload of data. And they could all manage themselves quite separately and quite effectively. And once I made that change, I didn't get a single issue in the service bus in terms of dead letters or message locks and things. So again, it's not a silver bullet. You just have to be really conscious of the limitations of the plan and adapt your code to work with it. I know of another organisation who's done a lot of work with functions and pushed them a really long way in terms of the amount of data they process. And the way they did that was by going to a zero allocation model. So if you follow Dave Fowler when he talks about ASP.NET Core, they're often looking to limit the number of allocations they make. And Engine, the guys who did this, and they've got some really interesting presentations. It was for illegal fishing, I believe, from memory, catching illegal fishing. If you search for Engine and look at some of their use of functions, it's really interesting. They basically made that work by working really hard to get the functions to a zero allocation model, or as close to zero as they could. And then you get a lot of headroom out of these things. So you just have to be mindful of the environment and be conscious that it's not a silver bullet. It doesn't just scale forever. It doesn't necessarily scale easily, but it will scale easier than most other, a lot of other sorts of services. I'm just going to take a quick sip of tea. 1 second. Herbal tea. I'll be up all night otherwise. So when I it's probably just before I did work for a charity, when I was talking to a charity, and I knew I was going to have to write a lot of these functions. Now, I spent some time writing functions previously, and they're quite painful to write if you've got to write a lot of them. There's a lot of boilerplate. They're quite low level. And I can show you what I mean just with, I should have in Rider, and hopefully everybody can see the text. If you can't see the text, drop me a message if it's too small. I can't actually find my mouse cursor. I'm probably losing my mouse cursor. Where's my mouse cursor? Ah, there it is. Okay. I think I'm going blind as I get older. Too small. Okay, let me just change it in preferences. That will stick for all the other work we're going to do. Colours, isn't it? Appearance, enter. Some coloured. Is that better there, or bigger still? I've not got the mobility stuff set up on this laptop, unfortunately, so I can't zoom in, but I will make it really big. How's that?
That's better, yeah.
Yeah, cool, great. Yeah, so that's a sort of sample out of the box HTTP trigger. So if you were going to write a REST API in Azure Functions, you'd have to write a whole bunch of stuff like this, and it's not exactly ASP.NET Core. You have an HTTP request, you have to form up responses, handle a lot of boilerplate in terms of processing responses, and if you've worked, obviously I don't know the background of people on the call, but I suspect you've worked with reasonably sized systems, and you've seen, these sort of copy and paste things devolve into carnage and chaos. And you can have the best of intentions around coding practices, but when the pressure's on, if something can break, it'll break, and standards and things like this we're looking at here quite quickly, I find, start to slip. So I didn't like the idea of that. I didn't want to build a lot of these things. So I started looking at other ways to do it, and I spent a lot of time with the mediator, sort of commanding mediator pattern, which we'll talk about in a second. And I really liked that pattern because it separated out business logic from protocol. So if you think about functions, they're essentially a protocol adapter. They look at HTTP, they look at the service bus, they look at the event grid, they look at the Cosmos change feed. They process very specific triggers, protocols, and you don't want your business logic getting sort of mixed up in that. And as far as possible, you want to separate it out. For portability, if nothing else, testability. There's a whole bunch of benefits to doing that. So I've been looking at this pattern, and I was thinking, I think I can do something with some code generation, basically, to make this work with Azure Functions, and me not have to ever write an Azure function. So I started investigating this, and Function Monkey was born, which has since become moderately popular. And if you find this interesting and you want to give it a go, I put a call out on Twitter the other night for contributors, because I'm struggling to keep up with things for people, and I'm not writing code in the day anymore. So with my sort of newer role, so if you find it interesting and want to get involved, then give me a shout. Fortunately, some kind volunteers have stepped forward, which is fantastic. But it's become quite popular, which is really nice, and people seem to like working with it. And the other thing that we've started to work towards is giving you a bit of an escape hatch. It's not finished, but one of the concerns that people have raised about functions over the last 2 or 3 years is the sense of lock-in. That you'd be locked into functions. That if they had a big application, it was based on functions. How do they get away from functions without writing a lot of code? Well, I come back to sort of the right pattern, commanding a mediator. And if you're never writing functions, you can press a switch and have it create a Docker container with an ASP.NET Core app and some web jobs, all the better. And if you look as we go through some of the code in the second half of this, we'll see how that might work. But I mean, the other reason as to why this makes sense to do, so I missed a couple when I was talking then. The event-based program model, which is what functions as a service is really, it's event-based. Here's something that's happened and here's its data. That's a really good match for a command pattern, because that payload, that description of what's happened, is a command. You could treat that as a command. So actually, it fits really nicely. And as I said, they tend to contain a lot of boilerplate. I really dislike approaches that have lots of boilerplate. I worked in an organisation as a consultant for a time, and they're a highly successful organisation, but their code, their sort of ethos seemed to be copy and paste, reduce simplicity by not making it complicated by copying and pasting, and it was insane because nothing ever worked in the same way, because over 2, 3, 4, 5 years, everything had become modified and slightly different, and the boilerplate had been tweaked. It was chaos, to my mind. So I really like to kind of stamp out boilerplate. I think it's the enemy of maintainable systems. And finally, the other thing is, if you try and build a REST API, it's going to be very difficult. You're going to have to do a lot of low-level work. There's no support for built-in authentication. You can do some stuff with EasyAuth, but token-based security is not straightforward. You just have to roll a lot of work yourself, and I didn't want to have to do that. So it's a really quick diagram on how commanding and mediators work and how it sort of fits into Azure Functions rather. Azure Functions are based around triggers. The one I showed you a moment ago was a HTTP trigger, but there's also service bus triggers, event grid triggers. There's all sorts of triggers, and they're all events. They trigger off events and then run some of your code for you. And normally what you do is you write that code from beginning to end. You write a handler for the trigger. What happens with Function Monkey is you just say, I've got a C# Poco, a plain old object, and I want that thing to be a command. And it's got some state, some payload, and you tell Function Monkey that you want that command to be associated with a certain trigger. So you'll say, this command maps to a HTTP trigger called X on this route. This command maps to this service bus queue. And from that, and some configuration of a builder, which we'll look at, which is quite simple, Function Monkey will generate all the sort of wrapping boilerplate for you. And if it's a HTTP trigger, it'll give you options like token-based security. So you can use an OpenID Connect provider. I'll do a demonstration of Auth0 here today. You can introduce validation for you, so you don't have to roll your own validation. It's kind of like an ASP.NET Core Lite. And I'll just come back to that in a second. Once you've got the command, it gets passed to a dispatcher. And this is where we enter sort of commanding mediator pattern. And the dispatcher is the thing that maps commands to something that will handle the commands, to command handlers. If you've got a command which is add 2 numbers, you have a handler that understands how to add 2 numbers. And you just associate those 2 things together. And that runs through something called a dispatcher. And that's the thing that's in common across the entire function app. And that gives us quite a bit of power around a lot of non-functional requirements, which again, I'll show you in a second. I mentioned a minute ago ASP.NET Core, and I mentioned that in some ways you could think of Function Monkey as an ASP.NET Core Lite for Azure Functions. Why not use ASP.NET Core is a good question, I think. And the answer on Azure is that they don't support it. You can make it work by using and I know some people have done this, so I don't recommend it. You can make it work using the test server. So you can get Azure Functions to run the test server and run ASP.NET Core and handle your requests like that. But the problem's in the name to me. It's a test server, and Microsoft are not maintaining that on the basis that it's running production code in an environment that needs to be secure. So that would terrify me. So you can't do it as of today. It's a commonly requested feature for the functions team. I don't know where it sits on their roadmap, if it'll ever come. You can do it on Lambda. So AWS Lambda supports ASP.NET Core applications run serverlessly. So you'd like to think Azure would get around to that, but they haven't yet. I think you also have to wonder at that point if it's the right fit. It won't deal with the service bus things. It's not going to cover the whole range of event-based programming that you might want to do in a significant system. Pardon me. So we're going to take a look at some code, which won't be code in PowerPoint and won't involve me typing. So something else I've not tried before is doing this through some pre-prepared kind of snapshots of code, which hopefully eliminate the typing, make it less boring, and eliminate the sort of where's the typo problem that you often get. And I'm hoping to get slicker of this and better do it just by rolling backwards and forwards through commits, but baby steps. Let me just close that down. Okay, so this is a starting point for an Azure function app, for a Function Monkey app. It's basically, and I realize you're not going to see this on the left. I wish I'd thought to enable that. Just 1 second. Let me put the zoom on. It's an accessibility, isn't it? Fine, that's better. So the Solution Explorer on the right here, if you ignore model and services, this is a pretty bog standard Azure Functions app, empty. You've got host.json, which is a standard file, and some settings whichever than the auth0 thing I've added, which we'll come to later, is just the out-of-the-box settings for the sort of template app. Now, I have got a bunch of packages in here. I've essentially added these function monkey packages, which I'll talk about as we go. But at a minimum, what you need is function monkey compiler and the function monkey package itself. The base starting point will have added the SDK, the functions SDK for you. But these two are the ones that you need to add to use function monkey. And the other things I've added in here, just scroll back out, are just some services. So what I want to do is just demonstrate a fairly simple to-do type application, the classic to-do. We used to build bug trackers, now we build to-do apps. Not sure if that's progress, but it's what we do. So I've just created a simple sort of repository, to-do repository with a create method, mark complete, mark a to-do item as complete, and get all. They take a user ID and a title. And the title is, I need to empty the fridge, that kind of thing. And I've done a really naive memory-based repository, which just adds to-do items to a list, and then finds them in a list and marks them complete as a list. So it's pretty simple. And I've got the model. I've got the to-do item. So it's a fairly simple model, an ID, user ID, title, and whether or not it's complete. So we'll do this as like a memory-based app. And what I'm going to do is basically imprint this interface, expose this interface using commands through Azure Functions, and that should be step 2, the sort of basic function app. Cool. Normally I'm doing lots of furious typing at this point. I've done this 2 or 3 times, and there's furious typing to kind of type some of this in quickly. It's not particularly conducive to an enjoyable demonstration, I don't think, so changed approach. The key thing I've added are the commands folder, the handlers folder, and the function app configuration file. And if I start with the commands folder, if we start with create to do item command, it's a simple C# object. We'll come back to this bit a little later, the security property piece. It takes inputs an interface called iCommand with a type of to-do item as its generic parameter. What that means is that pardon me, when we run the command, it will return the created to-do item. So that's the return value for the command. Commands can return the result of their actions, essentially. They don't have to, it's optional. And the way I tend to follow this as a naming convention is, this is called create to do item command because it changes some state. The next one we'll look at get all to do item query. This doesn't change state, it retrieves some information from the system. And you can see it inputs iCommand again, and a read-only collection of to-do items. So that will return a set of to-do items for the user. And finally, a mark complete command, which is probably what you expect at this point. It inputs iCommand, doesn't have a return type, and you supply it the ID of a to-do item, and the idea is that I'll mark it as complete. I then added handlers. So I mentioned that the commands are actually sort of executed through a command handler. What do they look like? Well, they implement iCommand handler, and as the first parameter for the sort of generic interface, it's the type of command that they actually handle, that they execute, and then the return type of the command if there is one. They support injection, so there's a constructor, and it takes our to-do repository that we looked at earlier, and each of the handlers will have one of these execute async methods on them, which is what that interface declares. And it takes the command. If we get time, we'll come back to previous result, but unless you do anything particular, that'll be null. You don't have to worry about it. And then what does this command do? It's really simple. It calls our repository and asks it to create the item. It's really simple. And interestingly, there's nothing in here that isn't business logic related. So the handlers are just about executing business logic. There's no HTTP going on in here. That we're going to put this through the REST API. None of that's in here. There's no security work in here. There's just look at some state and do something with it. Just do business logic. The get all is the same structure. It returns all the items based from the repository. Mark complete. Same again. Its return is just a task. There's no there's no return payload. So that's the handlers and the commands. The way we bring this all together is with a builder, which is in this file here, function app configuration, and a bunch of namespaces. My pet peeve namespaces I've left in there. Oh dear. Oh, it's better. Sorry, one of my sort of pet peeves is seeing that at the top of files. Yeah, so in the function app configuration, this is the thing that wires up commands and handlers and exposes them through functions. And it's a builder, and the class that we implement has to implement this iFunction app configuration, and that's what Function Monkey will look for. So when you compile this system, what Function Monkey is going to do is search the assemblies for one of these. When it finds it, it's going to execute it, and this code in here will run. And based on the results of this, it will code generate a whole load of functions that then get compiled as part of the resulting function app. So you never actually have to get into the functions themselves. You can write quite happily. You could go and write an Azure function sort of natively alongside it. There's nothing weird going on. There's nothing sort of crazy going on. It's just code generating a whole bunch of stuff for you and outputting it into an assembly, and it uses Roslyn to do that. And some handlebars templates is where the sort of source code comes from. And I know C#9 has got this new hideous looking, frankly, code generation thing coming, because when I last looked at it, it was like strings, which seems like a real missed opportunity, but never mind. I may well move Function Monkey onto that, or hopefully one of the contributors will. Inside the builder, there's a setup method, and it takes a certain iService collection, so pretty standard dependency injector, and it takes a command registry. The command registry will allow you to register the commands and the handlers with that dispatch that we saw in the diagram. Now you only need to do that if you want to do special things with the commands, and there's documentation for this which will explain what some of the sort of special things and special scenarios are. By default, Function Monkey will wire everything up for you automatically. It'll go and find the commands, it'll find the handlers and do the wiring. Then there's this functions block, and the functions block is where you say where you map a command to a function, to an Azure function. So here we're declaring a bunch of HTTP functions, and we're saying that all on this route, the route's called to do, and then on the route we add each of these functions on a verb, and you can do subpaths on there. There's a whole bunch of extra configuration you could go and put in there. There's a bunch of overloads for it, but the result of that will be 3 functions on the to do path, post, get, and put, matching our commands. And I should be able to run this. I'll just zoom back out. Okay, so if you've ever seen Azure functions run before, that will look very familiar to at the bottom, the local function host starting up. And at the end, you can see that we've got 3 HTTP functions running as mapped there. And it's generated some names from us based on the command names and the function type. And if I run them in Postman quickly, I've got some sort of pre-prepared payloads here. That's what I ran earlier, make sure my demo worked. If I just change the name of it, this is an example function. So that's the command payload. I'm not specifying the user ID at this point, we'll come to that later. Post it to the endpoint, and you can see it's returned, the console's run, it's run the function, and it's returned the created to do item. If we run get items, run that one again, that's our item we just added. If we add another item, I won't change the text. Run get again. We've got 2 items of different IDs, and they're both not marked as complete, but both is complete false. So if I just grab one of the IDs, that just gives a 200 response, and if we go to get items, the items be marked as complete. So you can see it's just running the functions as we'd expect. And as we hit those endpoints, FunctionMonkey deserializes the payload, the query parameters, all the kind of things you kind of expect with an API framework, and it maps those onto functions, maps those onto command payloads executed by the handlers. So it becomes quite a sort of nice environment to work in for Azure functions, because you're not having to worry about, is this thing logging this, is it doing that? And we'll look at how we address cross-connect concerns in a moment, because you can do that quite powerfully with this pattern. But hopefully you can see, it's fairly clean. We've got none of the attribute stuff going on. We've not had to do that much work. We've got a clean separation of concerns. And if we want to test everything, the thing we'd really care about testing is probably these handlers. We could test the functions. They're quite sticky to unit test to separate, but you could acceptance test for functions. But you can certainly do the handlers and cut out some of the awkward stuff that could come with testing the functions. So it gives you another sort of layer into it. So I mentioned some of the other stuff that FunctionMonkey will let you do. If we just add some basic validation to this, get rid of that. Next part. So if you're doing this, from scratch with Azure Function, you'd have to start building some of these hooks in to let you do validation in a sort of consistent way. FunctionMonkey has it built in, and you can see in here I've added a folder now called validators. If I open validators, just close all this stuff. Remember to do item validator. This is using Fluent Validate, which I don't know if you've come across, but I think it's an excellent framework for doing validations. It's quite expressive. It uses a Fluent API, hence its name. It's fully compatible with ASP.NET Core. I have used it with FunctionMonkey. You don't have to use it with FunctionMonkey. You can wire in any kind of validation system you like. It's extensible and interchangeable. But by default, there's a package called FunctionMonkey.Fluent Validation, which will wire up those things for you. So all you have to do then is write your validators. And this is a validator that says the title must not be null, and it's got to have a minimum length of 1. The other change we need to make that work is in the function app configuration, we need to add a couple of lines. So we add this line here, and this is actually a Fluent Validate call. We tell Fluent Validate to go and find the validators. And then we call add Fluent Validation, which is from the FunctionMonkey library, and that tells FunctionMonkey to use our validation, our Fluent Validate validation support. And if we run that now, again, it will run in the console, normal function app. Go to Postman. So if I do a get, there'll be no items in here now because we're starting from scratch, it's memory based. If I were to take the title out and try and create an item, you can see we've got an error generated with some an error code based on a validator name, the property, and the message, which you can configure in Fluent Validate. That's all coming from Fluent Validate. So quite easily you can add validation to this, and you can see I can build these out quite straightforwardly across a bunch of commands. And again, it's separating things out quite nicely. It's kind of sort of leading you down the path of least resistance is to separate things out quite cleanly. Which again, if you're working with sort of mixed capability teams, that can be really useful to give a team a path of least resistance to head down. if that's well, just the next one. Some of my work with some of the things that led me to these kind of approaches were doing that. We're working with teams and trying to give them some rails to run on. Just getting the right next one. Sorry. So another thing you might think you need to do is tweak the HTTP response. In Postman, sorry, 1 second. In Postman, we're obviously getting these HTTP responses back. What if you want something different, right? You want to shape it in some way as it comes out of a HTTP endpoint. And a good example might be you want to do something with an exception. You might want to actually not report an internal exception as an exception. Maybe the internal exception is okay. Maybe I could not find item in database exception should result in a not found status code. Or maybe you just want to log the exception. You can do that in FunctionMonkey with something called HTTP response handler. So the thing I've added here is this file. So HTTP response handler. And it's just got a bunch of actions that you can do something with. So if an uncaught exception arises, untrapped exception arises, you can inspect the exception and do something with it. And in this case, I'm just writing it to the console. But what you can do at the end is return a different iAction result. So you could return a not found code. You can tweak that however you like, and you can actually do the same with a valid response. So there's two methods here. One is a response with a result. One is a response without a result. You can go and shape those to return different text, different JSON, whatever you like. And finally, you can do that with a validation failure. So the one we were looking at a moment ago with the properties of things and the validation failure, maybe you've got an existing client application and you need the validation to express itself in a way that's compatible with that client application. We could reshape that here. That would be one of your options. And again, function app configuration, the only thing you need to do, oh, I deleted it. Looks like I've deleted it, that was a bit silly. Try and remember what it is. Default HTTP response handler. You declare that there, tell it to use that response handler as our default. You can actually do a different response handler on each function. So if you had half the functions, needing to behave one way, and the other half wanted to behave another way, we've all dealt with crazy systems before, right? And to slot into existing environments, you could do that with having multiple response handlers. I won't run through that. I'll move on because I'm conscious of time. Another common topic I've had with Azure functions was around authentication. How do you handle authentication? And I mentioned easy auth earlier. You can do easy auth. Didn't drop it in. Nice penguin wallpaper though. Everybody likes a penguin. I do. You can do easy auth, but that's quite limited. You can't get hold of access tokens. You can't get hold of claims in tokens quite not easily. And the way we've integrated it is you just get the claims principal ID passed through. Obviously, I can't cover all of how this stuff works, how authentication works in this session, although obviously John was talking about some of those bits and pieces earlier with Azure AD. Slightly different sort of topic though, but I can't cover all that here. But what you can do with FunctionMonkey is there's an authorization sub builder, and FunctionMonkey comes with a package for validating JWTs. And it just uses, there's no like crazy clever homegrown code in there. It just uses the ASP.NET Core frameworks for doing that. But what it does do, which I think is quite useful, is if you've got a bunch of claims in there in your access token, so maybe you've got a user ID, as I have here. I'm using the service, the principal, the name identifier, which is going to be the ID of the user. You can map that to a property on all your commands. So when we were looking at the commands earlier, we had a user ID on them. What you can say is, I want that user ID on all the commands to come from this claim in the access token. which again means you can kind of scale this out quite quickly, quite straightforwardly. If I run this now, we'll see how this will work. I should add very quickly, the security property. Obviously, it would be really bad if somebody could put that on a HTTP post payload, if it could inject it somehow other than through a trusted identity provider. So security property means that will never ever go near deserialization and query parameters or anything like that. It can only be populated through an identity provider and through an access token and the claim you specify. So it keeps it secure. Okay, so I've run that up again. If I call this now, so that's create. I think I've got a token here from earlier. Sorry, 1 second. Right, okay, that's better. Right, so if you know if that works, I'll explain why it works in a second. When I try and access this now, it's unauthorized. I can't get through to the endpoint. So what I need to do is get hold of an access token, and I've got one configured here to call Auth0. I'm just using Auth0 as an identity provider, and I'm going to get an access token out of it, a fresh access token. In this case, using client credentials, so using a client ID and client secret, just because it's quite convenient to do here. If I go back to the create item and I go to authorization, bearer token, add a fresh bearer token, let's create, I need the title, so add the title, some item, create it, and we can see the user ID is now populated, and that's come from Auth0, so that's come from our identity provider. So now we can secure our endpoints, and we can map properties about our users from our identity provider onto our command payloads. And again, throughout all this, you may have noticed I've never once opened up one of these handlers. So I've never come in here and gone, right, I need to change some code. I've never gone into an Azure function and started adding code. It's all been declarative and at the top, it's kind of top level. So you can separate all these things out and could quite easily put them under another host. You can run them under an ASP.NET Core quite straightforwardly. So one of the things I mentioned, sorry, I'm a bit of a senior moment there. It's been a very long day. One of the things I mentioned was handling kind of cross-cutting concerns and NFRs. And again, we've probably all seen code where it's still shockingly common. It surprises me. And I guess it's a reflection on us as a development community, but we've still got work to do. You see in ASP.NET Core, you see controllers with log this written in it, and lots of audit this and audit that, and repeated across lots of these controllers. Now there's ways in ASP.NET Core you can do that in a cross-cutting way. I think ASP.NET Core is a great framework. FunctionMonkey lets you do it in a way that isn't tied to the protocol. It's about the pattern, about the underlying portable pattern. We could run this in ASP.NET Core. We could run it in Azure Functions. We could go and run it in a console app. It's portable. And the way you would address this in this environment is inside of a dispatcher. And if you recall, I showed up a dispatcher. It's for one thing. Everything runs through a dispatcher. It's kind of like the central coordinating hub of everything. And what FunctionMonkey lets you do, or the underlying sort of commanding framework lets you do, is implement your own dispatcher or decorate the existing dispatcher. And here what I've done is I've decorated the underlying dispatcher by injecting it into my custom dispatcher. And then I've overridden the dispatch methods to basically just write something to the console here, and then dispatch the command through the underlying dispatcher, which I'm doing, one of these is for one with a result, and one is for one without a result. And we won't worry about associated executor for now. In fact, you'd never use that in Azure Functions. But you could see how you could top and tail this with auditing code. You could do all sorts of things in here. You could inspect the commands, anything that kind of cuts across all the commands, or even a subset of the commands, because you can check the types of them. You could do quite nicely in here. And every time a command is run, as we'll see, we'll see that this thing's run. So if I run this now, just bring up Postman, and I'll create a to-do item again. And the pause now it runs is that on the first time, but the reason it's pausing now is that on the first time it has to contact Auth0. It basically downloads the well-known configuration from Auth0 on the very first run. So that's a slight pause. Won't happen on subsequent API calls. But you can see now IMM and dispatcher is in the console. So that was on I did create. If I do, if I go and do get items, and scroll that down again, that's unauthorized, so I just need to go and get the bearer token, the access token rather, get items, authorization, bearer token. Okay, so I've run that, and IMM dispatcher, you can see it's running on each one. We could just go and do something like just run that again, make it a slightly clearer demo. And run the create item. IMM dispatcher create to do item command. IMM dispatcher get all to do item query. So we can address our cross-cutting concerns through the dispatcher. And to add to the dispatcher, all you do is replace the existing dispatcher in the dependency injector with the new dispatcher. That's it. That's all you need to do to sort of add that functionality. And finally, just to touch on other trigger types and output bindings. They work in the same way. So this demonstrates using a service bus queue. You see there, .service bus at the end of the function block. Exactly the same structure, takes a command. It's a queue function on the service bus. You do have to add, this is an Azure Functions thing, you do have to add the, let's find one, these web job extensions. So when you use the different trigger types other than HTTP and timer, you have to add the appropriate accompanying web job extension package from NuGet, else you get a runtime error, which is a little bit unfortunate. So you have to add those. But otherwise, it's exactly the same code. And just to show also how output bindings work. So one of the things you can do with Azure Functions is when it's run, when the function's run, you can take the return of your function and send it to another kind of resource. So you could run a HTTP function and send the output to a service bus queue. You could take a service bus queue and take the output and put it into table storage. And that can be quite useful to let you chain things together. If you've got a series of things you want to happen, and perhaps things you want to fan out, that's a quite useful technique. Stops you getting involved in code which is, composing the messages. So in this case, what we're going to do is we're going to take the to-do item command, the to-do item model that came off the back of the create function, and we're going to output it onto a service queue called myQueue, an invented name that I came up with earlier. And then we're going to have the service bus, a queue function, just read it off the queue. So nothing particularly earth-shattering. To support this, I've added a command called to-do item command. And I've been a little bit lazy, just to get the demo going quickly. It inherits from our to-do item model and implements the iCommand interface. And then I've got a command handler that just writes something to the console. So we received it on the queue. And if I run this, I'm not sure I ever tested this. So we'll find out, I guess. I'm pretty sure I created a queue. Postman, create to do item, create item. Yeah, fine. So I did create the queue and received on queue. So our trigger, our HTTP trigger ran. It ran our handler. Our handler returned a to do item, and we then placed that to do item on a queue, just using that little one-line bit of syntax. And then we had another function read it from a queue. And I think hopefully you agree it's fairly simple. There's not a lot of work to make that work, and you can see there's a variety of trigger types, output types supported there. There's some more it'd be useful to add. Azure function supports quite a few. It's just a question of time, on my part, and hopefully contributors now too. There have been quite a few contributors over the last year. I should mention. I'm mentioning new contributors. There's a support for quickly Open API, so you can go and if you wanted a Swagger document to be created, you can go and create just use a builder to create a Swagger, an Open API endpoint, and it will include the user interface, it will include the documentation. There are on the functions, and this is something that a contributor very kindly added on the HTTP functions. You can go and annotate them with Open API responses and things. That was a contributor contribution. I'm very grateful for. Yes, there's a whole bunch of stuff in addition to what I've shown that all follows the same pattern. Always quite straightforward to use. It's really well suited to those kind of like back-end things and some kinds of API. So I wouldn't use it for in a situation where latency was important for me. So in my cycling application, for example, latency is important to me. I want that to feel snappy. It's important to me that I'm less worried about the cost to run. I'm more worried about user experience being responsive and feeling really immediate, because it's one of the issues I have with the sort of competing cycling apps is the user experience isn't present for a variety of reasons. So that was really important to me. So it made functions not a good fit for a REST API. And I mean, that happens written in F#, but it's fundamentally uses ASP.NET Core to do its API. But then I use this stuff to do the backend, to do the sort of number crunching and coordination of backend activities. And it's a really good fit for that Azure functions. I've used it a lot. If you want other examples of where it's been used a lot, I've used it a lot in ETL scenarios. It's great there to just in comes as something off a queue, you want to drop it into a warehouse. It's fantastic for that. Use that sort of buffering scenarios too. So if you've got like a dispatch point, a batch update point, to build a batch and then send a batch when it's ready. They're really good for that. Anything in that space, I think they're really good for. And I'm pretty much done at that point. I'm just about on time, which is amazing. If anyone's got any questions, I'll be happy to answer them about Azure functions or the code we've talked through. I'm always happy to talk on Twitter. Is the easiest way to get hold of me. If you've got any questions about it or functions or Azure in general, I'm always happy to chip in and help. And then there's the GitHub page for this particular project, where I do try and answer issues. I've not been very good at it this year. I've changed job 6-7 months ago to move into a non-technical day job role. And it means at night I just want to write code. I just want to write code for myself. So I've done less sort of community open source work, but there's quite an active bunch of contributors around it who answer issues and help. The packages for functions v3 are marked as in beta, but they work fine and they're in production. The reason they're in beta is I won't nudge when you get packages along. Again, while I was sort of asking for help this week, because I've become a bottleneck to the project really. Which is not great because there's quite a lot of people using it. But yeah, so if you've got any questions, happy to answer. Otherwise, back to Ryan.
Yeah, feel free to come off mute and ask a question or drop it in the chat channel, and we'll happily ask it away. Just wanted to say thank you, James, for that. That was really good.
Great, thank you. Thanks for inviting me to come along. I'd hoped to come in person. I spent quite a bit of time in Doncaster, when Ryan first mentioned this group to me, I'd hope to sort of come along in person, but maybe later in the year.
Fingers crossed. We are planning an in-person event if we can get to it. It will be at some point, maybe at the tail end of the year, depending on obviously what's going on with the current environment. Maybe next year, we will just have to wait and see, but we will continue to do online sessions until then. We may even do sort of a hybrid model where we have a remote presenter come into an in-person event, which can also be joined remotely.
Yeah, great.
See how things go and how things progress.
Yeah, it's got very unpredictable, hasn't it?
Yeah. But looks of things, there's no questions that I can see going in the chat channel, and nobody's coming off mute. I can tell either. So okay. I'll end the recording there, and thank you again once for your time.
Yeah, no, thanks for inviting me. I enjoyed coming along. And it's the first time I've done a meetup or conference thing on purely online. It's quite an unusual experience. So talking to a